Hi, I'm Patrick, and I'm from Team Quarantine, and we're here today to tell you about Wormplay. Wormplay. It's a play on worms. And what is Wormplay? Well, our initial concept for Wormplay was what if you could take a popular word game that for copyright reasons will remain unnamed, but instead of putting your letters onto a boring, unmoving bit of cardboard, you could drag and drop letters onto a moving cartoon worm. That sounds pretty good, right? But Wormplay is also so much more than that. Wormplay is a two-player online game that uses WebSockets to feature real-time interaction between players. It also has a lobby system where players can sign in with a username and then they can meet up with friends, create new games, or they can just challenge a random stranger to a game of Wormplay. And last, but certainly not least, you can put your own face onto the worm. And if that doesn't make you want to see the gameplay, I don't know what will. So on that note, I'm going to hand over to James, who will walk you through the game.
Hello, hi, my name's James and I've got the great pleasure of talking you through our Wormplay demo today. So this is our login screen and here you'll be putting in your handle that everyone else will see for the rest of the game. So I'm Lone Star, the fastest worm in the West, and I'm just going to jump in quickly. Now here is our lobby. It's dynamically generated through sockets and you can create your own room and join in. So I'm just going to create one here. I'm going to call it the Alamo because I'm a Texan worm and I'm just going to create that now. And this is a basic overview of how the game works. You can see our room here at the Alamo. We have a live chat system, and up here are a number of tiles that you have to drag and drop onto your worm. The goal is to create the longest worm and submit it within the time limit for the most points. There are two worms, so you do have to play it against an opponent. So I'm going to leave this game and go join a game that my friend Nadia has set up over in Newtonville. Now, some of those eagle-eyed amongst you will notice that we do have some facial recognition going on the right-hand side. So what you can do is pull a number of silly faces, and they'll display on your worm, and then any faces your opponents take will display on their worm, so you can see each other. So I'm just going to pull some faces now. So I'm going to do happy, shocked, angry. Oh no, not. Is that angry? Yeah, that's angry and sad. And I'm just going to join in with Nadia there. It's always a lot of fun making those. Just loading up the game now. So as you can see, I've got my happy face there and Nadia's face here, and I have to drag and drop a word onto here. So I'm just going to do. And as you can see, when I drop it down, Nadia's face changes when I drop it down. So I'm just going to submit do for 2 points, and I'm not sure Nadia's got anything. Oh, she said B, so she won that round. As you can see, my face has gone to sad for the in-between of the round, and it's currently staying sad because Nadia has a higher one than me. So I'm going to try spell the next one, so I'm just going to do Met. Oh god. So the music score in the background was composed by our person Patrick, and I win with Met, so it's one apiece, and you can see our faces have gone back to happier side, but our facial capture system has me looking a bit gormless over there in the side, and I'm not quite sure what I can spell with this one. Maybe moo? Or mop. Mop might be good. Or should. Nadia is very good at this. She does play about 26 hours of crosswords a day, so she is pretty lethal. We do have a scoring system, so it goes off to an API and comes back, and then different words or different letters are weighted for different values. So sometimes you can clip someone with having a more complicated word in terms of how few the letters show up in the English language, and sog, dep, des, d, like the German the. No. So it's a draw. I'm not sure why Nadia's word didn't work. Maybe hen. Oh, jog. She's clocked me. So, no. So you do have to click the submit button up at the top in order to get it to work. It is 2 apiece. Now the rounds are up to best of 3. So whoever wins this round is going to win the game in total. So let's maybe go for Gab. Like, shut your Gab. And then hopefully... Oh, she's done Beak. And that's it. So Nadia's won. and that's the end of the game. So I'm just going to leave and go back to the lobby, and that was a demonstration of our Wormplay game, so I hope you enjoyed it. We had a lot of fun making it, so yes.
Hi all, I'm Nadia and I'm here to talk to you about our Wormplay backend tech stack. So our backend was written purely in JavaScript. This is because it's something we'd learned at Northcoders. We were all very comfortable with the JavaScript language, so we chose to use JavaScript in our backend. Next, we created our server with Express. Now, Express is a HTTP server, and we implemented Axios, which allowed us to make them request to the Oxford Dictionary API and validate the words that were submitted. We also used Socket.io, and that allowed for us to have real-time communication between the backend server and the Phaser game. We hosted our backend with Heroku, and we chose Heroku because, again, we had used Heroku in a previous project and we were very comfortable with how we would implement and host our backend.
Hi, Chris here, and I'm going to be telling you about our front-end stack. We primarily used React and Phaser. Now, Phaser is an HTML rendering engine, and it's what creates our game. Patrick will be telling you more about this in a moment. We chose Phaser because, first, our research showed that it was one of the best tools for creating a two-dimensional game with physics, with interactable pieces, and secondly, because it was a brand new piece of technology for us, one that we hadn't learned on the course. At many points in this project, we really strived to adopt new pieces of technology, new libraries, new frameworks, and really broaden our horizons and push our limits in terms of how much we could learn in a short space of time and integrate together into one coherent application. So we also used React, as I mentioned, and we chose React because it's a single page application framework, and we wanted to simulate the experience of multiple pages, but ultimately it's one page that the user is accessing. So you go to the login, takes you to the lobby, takes you to the game, but it's just this one page. Because that also allows us to then render the game inside it and so on. And then finally, over here we've got TensorFlow, and this relates to our facial recognition, which I'll be talking about later. So, on to Patrick, and he'll tell you about the phaser.
So, to create the main gameplay element of Wormplay, we used a framework called Phaser 3. Now, Phaser 3 is a JavaScript framework for making 2D games in the browser using JavaScript and HTML that is mainly based around using the HTML canvas tag, in that it renders the game on a canvas tag. It is an object-oriented programming framework with inbuilt methods and classes that allow you to do a lot of things. For instance, game objects can interact with each other and with users, as you saw with the drag and drop letters earlier in the game. You can create animations to move things around the screen, as you saw with the moving worms. And you can even create scripted and timed events to happen. For example, the countdown that runs throughout the rounds, and the fact that a round ends when the countdown reaches 0.
Hi, Chris here, and I'm going to tell you about facial recognition and data management. The first is about us breaking apart an existing piece of technology, and the second is about us building up our own custom framework. So, facial recognition. This was an existing API built on TensorFlow. It recognizes what is a face, draws a blue box around it on the webcam, recognizes who you are, what your emotion is, and we didn't want to just take this wholesale and slot it in. Instead, we wanted to open that box, break it apart and understand each individual part of it, how it worked and what it was doing. Because some parts of it we didn't want. Don't want it to recognize who you are. We're not going to use that in the project and might slow everything down. Can we get rid of that blue box around your face, just aesthetically? Although actually, we still need to use its coordinates so that it takes a photo of your face wherever you are on the screen to put on the worm. So this was a really enjoyable weekend-long spike of breaking apart this facial recognition tech, working out which bits to take out and which bits did what, and how to integrate that into our project. So in addition to this, and the converse of it, we were also building up our own custom framework for data management. This was a key challenge that we had in this project. We really broadened our horizons by using a range of different technologies that were new to us, learning all about them, and we also faced the challenge of making them work together. In particular, Phaser, that shows you the game, React, that shows you everything else, the lobby, the chat, the login. Making these two work as one, pass data between each other in real time, immediately. This was something that we put a lot of time into researching. There's a lot of documentation on both, but not on both together. And so it was a very enjoyable process of each going off individually, doing our research, coming back, feeding back to the group, updating each other about where we were, building on top of each other's work, and eventually creating a structure that worked for us. A specific tree of where data is passed, when it is passed, which components are created inside which other components, and so on. And we made sure, for communication purposes, to extensively document this in our README file, so that all of us working on the project at any point, oh, I'm working on something totally different, I'm working on the points, but I need to access the username. Well, that's from React, because that's from the login. Great, it's here in the README. Explicit instructions from the other team members about exactly where to find and how to access each of these pieces of data. So it was a really enjoyable challenge, and one that I think we did a really good job of bringing together these different pieces of technology that were new to us and integrating them together and passing data between them as one coherent application. So we had our facial recognition, breaking apart something existing, and our data management, building up our own custom framework. I'll pass you on now to Nadia, who will tell you about the sockets.
So I'm here to speak to you about Socket.io. Now, Socket.io allows for real-time communication between a server and a web browser. This enabled us to create some really cool features on our game, which include the instant messaging that you saw earlier in James's game demonstration. It enabled us to create Socket.io rooms, which means you can play against one person only. It allowed us to create the lobby area, which showed you all the available rooms that you can go and play in and whether they're full. And I've created a diagram here where you can see the relationship between the Socket.io in the backend server, the React Phaser app, and the client. So this helped us to create this real-time game where you can see the opponent's scores, you can see where the worm is on the opponent's screen, and you can see the word submissions in real time. So this is why we chose Socket.io, so we could make a great real-time game. We used the Oxford Dictionary API to validate every word that was submitted during gameplay. So we used sockets to display and record the scores of both players in real time. So I've created a little diagram which shows the process in which the word is submitted, and I'll talk you through that now. So initially, the word is submitted by the client in the Phaser game. Phaser uses a socket to emit the word to the server. And what the next step is, the server then makes a request to the API to validate that word. Now, upon validation, the score is updated and sent back to Phaser, and then Phaser displays the updated score and the message. So that's how the Oxford Dictionary API worked.
Due to current events, we had to develop Wormplay entirely remotely, whilst also maintaining agile development practices throughout. Needless to say, as this was the first major group project undertaken by any of us as developers, this created quite a challenge, and the added challenge of it being entirely remote was quite daunting at first. But we managed to make it work using a number of digital technologies. So for example, we used Trello as a virtual Kanban board that allowed us to create, assign and work through tickets and keep on top of how the project was progressing. We used Discord for voice chat and for twice daily stand-ups that allowed us to keep track of each other's progress and make sure that there were no issues that one person was being particularly stuck on. We also use Slack for regular group messaging, imaging, link sharing to share resources with each other that we thought we'd find helpful. And we used VS Code Live Share for pair and mob programming to help when people were particularly stuck, or just sometimes it was better to pair two heads are better than one. We also use Google Drive for tracking files and variable management across React states.
Hello, hi, my name's James. We're joining us here in my kitchen. I'm just going to talk you through some of the challenges that we had making our Wormplay game. So the first big challenge is that phaser-free doesn't really mesh well with React. You kind of have to build a phaser-free game and then embed React into it afterwards. And while we decided we were up to that challenge and we thought that we could do it, we didn't really stop and think whether or not we should do it. And later on, when it came to the pragmatics of hosting it, we really could have done more research earlier on to help avoid that. Another challenge that we had is that most of the technologies we decided to use are actually brand new to us. So while we became very good at independently learning how to use these new technologies, making sure everyone else in the group was informed on how to use these technologies was a challenge in itself. The other thing that we had was that we used sockets and they were embedded into our phaser, our React, and also the video feed. And getting these all to copacetically communicate between each other was another challenge as well. Lastly, tiny challenge was that we didn't really spike into file management for phaser-free games. And so as our project became bigger and bigger, it became slightly more unwieldy as well. But that's it for me.
So for our final slide, I want to talk to you about some thoughts we've had for future development and some features that we would have implemented if we had more time. Now, there's a few things on this slide, so I'm just going to pick a few off to talk through. So first of all, we would have loved to have created this as a mobile app. Now, it's currently a desktop app, but we would have loved to have that feature for our game. Secondly, we would have loved to have had the webcam take pictures during gameplay. This was a feature we tried to implement initially, but it was slowing down the game and the user experience wasn't what we wanted it to be. So we decided to move that into the lobby area. So again, given more time, we would have loved to have implemented that feature during gameplay. And finally, we would have wanted to spike hosting earlier on in our project. We did leave this quite last minute and it caused us some issues, so we weren't able to do it in time. Again, if we were given a few more days, we would have been able to implement that and have that live in time for our project presentation. I'd like to say thank you for listening, and if you do have any questions, please leave them in the YouTube chat. We're all online at the moment, so we're able to respond. Thank you.